Hey YouTube, JP Dillon. We're going to do something a little off the ordinary from what I normally do. This is a 1930s Aztec cathedral radio, and this was brought to me by a viewer local here to San Diego. And his father had a radio repair shop back in the 1950s, and this is something he held on to. So the guy pretty much grew up with it through his childhood, and for some reason it stopped working and it got put aside. Aztec, I believe, was a company that started by a guy named Fred Stein back in the late 1920s, and he spared no expense on these things. Best top quality components you could get at the time. Nice woodworking, nice grill cloth. This one looks like death, but it's also been sitting in a basement for probably 30 plus years. So I do have the knobs and stuff in a bag. If we just want to flip it around here, the chassis is still loose in here. You can see it's been, for sitting in a basement, it's okay. There's no real model number on it that I can discern. 60 cycles, 50 watts, but the model's been obliterated on it. There's the serial number. It uses a pretty fancy Magnavox electrodynamic speaker. And I have ohmed out the field coil, so that's alive. For the most part, it all has original National brand tubes in it. This is a TRF receiver. Here's the knobs that I confiscated and stuff. So my goal is to see if I can get this thing to run. So it's going to be kind of a resurrection. You can see the wiring's all crumbling apart and in pretty bad shape. I have no idea if this thing's even capable of running. This typically isn't the type of thing that I work on. But I guess the first thing I want to do is replace the crumbled wiring in the cord. Obviously, the cord's pretty well done. And then we can check a few other things and power it up and see if it catches fire or see if it takes off. So let's just kind of get the chassis out and take a look at it. Okay, so I'm still tethered to the speaker, but here's the chassis out of the cabinet. And we see a date code here, April 20th, 1932. You gotta hope that these coils are still intact and they're not trash. The transformer doesn't look burned or anything like that, but that's kind of hard to tell. Unfortunately, someone's been chewing on that, so hopefully it's not dead. There's a lot of rust on the tuning condenser too, so it's really not known at this point whether this one's gonna resurrect or not, although this turns freely, which is a good sign. Someone stole the little dial lamp out of it. Let's just kind of flip it up here. I guess somebody replaced that filter a while back. And then you've got this tie-in resistor thing over here. It's green and purple. That'd be what is it, 5 and 7 or no, 5 and 7, 57 ohms. That seems pretty low. It's got to be more than that. All these scary paper wax capacitors, they gotta go. Resistor to the chassis here, and then these things with the nuts on them, those are your filter caps. I have a fair suspicion that they're dead. And then there's your, I don't know if that's a tone switch or a band switch. Look on the front of the machine here, and no label for it. Then you've got that big fat wire wound, looks like wire wound by hand resistor. I guess, I don't know if this is a volume control or if it's one of those designs where they run the amplifier wide open all the time, and this controls the cathode of the RF stages to adjust the gain of the RF, and it's the same volume all the time. Don't really know. I haven't been able to find much of a schematic on this thing. I've looked through all my writers and my SAMs for the 1930 through 32 years, and I can't find anything that on Aztec. So yeah, and then there's this loomed wire mess back here. All this old cloth wiring just really kind of disturbs me. But in any case, let's just do a brief check of the filters. I'm pretty sure they're going to be open, but why not? Alright, so let's see what our filters look like here. Here's filter number 1. Really? Really? And here's filter number 2. That one's dead. That one doesn't even register. Then you've got this. I'm assuming that attaches there. That filter tests awfully good. I wonder if it's got a short in it. And then let's see here. You've got this filter here, which it's still kind of alive. Let me get another meter and see if there's a short here. Alright, so using the VOM that I have, I like this little RCA. It's a WV519A. They're not cheap, but when you can find them, they're good meters because they use a 22 volt battery. And so it puts enough current through the thing that you're testing to reveal leakage on some transistors, to reveal a short circuit or something like that. So if we test the dead one, we get about 2K of resistance to ground. Yeah, it's about 2K. And then if we test the good one, that's not very much at all. 500 ohms and slowly crawling downward. Yeah, I'm not so sure if I like that. Let's put the full 22 volts on it. That just measures a short. So putting 22 volts across that capacitor, it's measuring a short. So whereas the other one also measures a short, but slowly charging, very, very slowly. So both of those have to go. Both of those filters need to go bye-bye. And then if we come over here to this capacitor here, not much of a change, but it could also be because it's tied into that same network as the rest of the filters. Just coming over here. Yeah, all these power supply lines, on all these plate lines for these capacitors, that these capacitors are attached to, show like very low resistance. So we need to take care of the power supply before we do anything else. Because right now, if I try to power this thing up, assuming the transformer isn't been injured by whatever rodents were chewing on it, would probably die from an overload because of those filters. So what I'll probably do, these typically don't need much filtering. I mean, they were like 10 microfarad, 20 microfarad at most. So I could probably get away with using 22 microfarad. I've got 22 microfarad at 450 volts. That'll be more than adequate for those. And that's only a 2 microfarad. And that was getting pretty high ESR for that too. But that could, again, because it's tied into that network. Anyways, enough rambling. Let's get some new filters in it. And that's boring. I'm not going to show you that. That's boring. I need to replace the wiring to and from the field coil, and replace the power cord, and get it so that we can turn the damn thing on without it risking a fire. So I'm not going to show you all that, we're just going to do that, and then I'll show you the finished product, and then we'll fire it up and see what happens. Alright, so to spare you the boringness, I've got the capacitors replaced. I took the dead filter and mounted a terminal strip to it to provide support for things and isolate things. We've got two 22 microfarad 450 volt. I replaced the giant Aerovox 2 microfarad with two ones in parallel at 450. All of the coupling caps here are new Panasonic films. I've replaced the power cord. I've replaced the wiring to and from everything. Replaced all of the frayed rubberized wiring. And so now we're at a point where we can turn this thing on and see what happens. And I honestly have no idea what's going to happen. This will be a very interesting thing. I've got it in series with a 40-watt light bulb. We're going to see if it'll pass the smoke test, see what it does. So without further ado, let's see what she'll do. And as you can see right now, that gets pretty damn bright. And it's not getting any less bright. So that makes me wonder if the poor transformer is dead. Looks like he got back here and definitely something chewed on it, or he took the windings down. Let's see if any kind of AC voltage is coming out of here. $100 millivolts. Not much. There's 600 millivolts. Ooh. Pretty much everything's being eaten up by the light bulb there. Now, it could also be that because it's a direct heated rectifier, the rectifier tube could be bad. I haven't really tested it yet because I don't have anything here to test it with. Don't smell anything burning yet. Transformer core is not warming up. So let's pull the rectifier tube out. Alright, so rectifier tube's out. See if there's any change. There is. You can see it's getting dimmer now. That's a good sign. Getting really dim. Good. So that tells me that the rectifier was very likely shorted. Question is, where am I going to get a number 80 at this hour? Now there are ways to combat this. That's a full wave rectifier. Let's see what's coming out of this transformer now that we don't have a short circuit. We come here, we've got 305 volts there. Yep, 305 volts. And then here, 3.6 volts AC. I'm guessing that's filament because of the draw with the light bulb. So unloaded 305 volts, that at least tells us the transformer isn't shorted. It's not heating up. The core is still nice and cool. That's a good sign. Now let's see. If we take a look down in here, that's obviously where it comes in from the transformer. And if we follow these lines, one of these lines is going to go to our main filters, and I can probably just ohm that out. So if we want to get really tricky, we can clip a bridge rectifier in here to get our high voltage up, and then see what happens. Want to have a little fun? Let's try that. Alright, so we've got our bridge rectifier wired up like a heroin addict, and we've got our ground low side of the rectifier chassis, AC input, and then our output. And those two pins are tied together, so it doesn't matter which one I go to. So now we're going to see what it's like under load and see how pissed off it gets. So let me grab our cord here and let's see what happens now. Maybe it'll work, maybe it won't. Let's find out. And it's nice and bright again. So obviously we got something going on here. Got 35 volts DC on that. .42 volts. So this is before the field coil, and this is after. Let's try a 60 watt bulb instead of a 40 watt bulb. Yeah, 60 watt doesn't help anything. Got 50 volts and 62 volts. Nah, it's still drawing too much current. So there's something else wrong here. Now one thing you notice is this burned resistor. 41 on one side, 38 on the other, so it's not pushing too much current through there. I'm not sure why there's this big set of loading resistors here on the secondary, but that wouldn't have affected everything with the rectifier out. It only seems to be under load that it cares. So this is very interesting. Something wrong here. I suppose the next thing we can do is start taking stuff out of the load circuit and see what happens. So we got the rectifier out, but you know, maybe this wasn't bad, because when I put the solid state one in, it just pissed it off equally as much. So let's pull something else out. Let's try the output tube next. Alright, so we've got rectifier tube out now. Or excuse me, output tube's out, rectifier is back in. Let's see if there's any change. Nope, not really. Nothing different there. Still don't smell anything burning yet, so that's good. Burning's usually a bad sign. There's not enough current flowing to heat up the heaters right now, so. Just playing around. Nothing there, nothing there. Let's see here. 1.5K off ground, 1.7K off ground. I haven't found any hard shorts since changing this out. Still no voltage generated yet. Alright, so the output tube didn't solve anything. Let's try some of the RF tubes. Alright, so our RF tubes are out. Now what? Now let's see what it does. Still bright. No good. So there's something going on in the load side of the secondary. Because once we take the secondary out of circuit, it seems to be okay. But the maximum this is supposed to draw is 60 watts, and as you can see, we got a 60 watt bulb in there that's burning nice and bright. And it doesn't care what tubes are out until you get to the rectifier. You remove the secondary from the load, and this problem goes away. Unloaded, there's 305 volts there, but trying to load it, and it doesn't make it very happy. So the things we have to ask ourselves are, what's in the secondary that could really mess this up? And one thing is the field coil, but that ohmed out at 2500 ohms. I get 2500 ohms between the output of the rectifier and the first filter, so, and that's where this runs down. There could be a short between there and the center tap. Of course, I don't know where the center tap is because I don't have a schematic diagram for this. There could be something else going on. Could be one of these components here is defective, although I doubt it. I changed all the film caps. I don't see any obvious short circuits here. But one thing's for certain, if we pull out that rectifier tube, it's sure, the load sure goes away. See that? Pull the rectifier tube out, bulb goes out. And that doesn't matter whether it's a solid state rectifier or what, but it certainly doesn't like that. I can hear the transformer buzzing away. So this is a head scratcher. I'm thinking either something in the transformer is defective, or we've got a short downstream somewhere that I just haven't found yet. Alright, well, we're back to the solid state rectifier, and I've gone up to a 95 watt bulb, and I think we're just going to do the smoke test and see what happens. I have a feeling that probably something in the secondary is shorted, and so that could be why it got parked, was because the transformer was bad. Because even the 95 watt bulb gets scary bright. That's over an amp of current right there. And it definitely should not be drawing an amp. We've still only got 44 volts, which is not much different than what we had previously. We have 77 there. And what's coming in? What's coming in from the outside? Let's find out what that is. So we got 25 going in, 77 going out. That's pretty, that's significant. Let's see what's going into the rectifier here. Yeah, 70 going into the rectifier and 70 coming out. Very little insertion loss. It's going up to 80. Ah, there's the smell. Let's have a feel here. Oh yeah, that transformer's getting toasty. So that's why it was parked. It was parked because there's a shorted turn in the secondary. That sucks. So really, in order to fix this, I would need to have another transformer. That bites. It's getting nice and hot. Bummer. Well, sometimes you win, sometimes you lose. Now, somewhere in my vast treasure trove of things, I do have a high voltage power supply. We could feed this thing and see what happens. That could be interesting. Since the high voltage secondary, when it's unloaded, we still get filament voltage, is probably a good bet that we could get this thing to fire up. But, God, that's a bummer. That's a real bummer. Might be able to pull something apart and find a power transformer that would be suitable for this. But for now, it's done. It's just getting hotter the longer it sits there. And I could totally just juice it until it flamed out, but I don't need that. Don't need that smell either. Well, if there is a part 2 to this video, it will probably be me digging up a high voltage supply and seeing if we can make this work. I would guess around, I don't know, 250 volts or something would be what it would need. Though I don't really know. Gotta find a schematic for this thing. So anyway, guys, hope you watched this cool little diagnosis. And if there's a part 2, there's a part 2. If not, and you'll see other stuff to come soon.